We are looking at this problem, lowest common ancestor of a binary search tree. We are given a binary search tree and we need to find the lowest common ancestor for two given nodes. These nodes are P and Q and we need to find their ancestors. These nodes are called descendants. Let's take an example. Let's say the value of P is 0. Let's say the value of Q is 5. We are over here 0 and 5. Their lowest common ancestor would be their closest ancestor. What would be the ancestor of 0? 2 and 6. So 2 and 6 are the ancestors of 0. 4, 2 and 6 are the ancestors of 5. Which one would be the common and the lowest? And the answer is 2. 2 would be the lowest common ancestor for 0 and 5. Let's take another example. Let's say P is 2 and Q is 8. Then their lowest common ancestor would be 6. What if P is 4 and Q is 5? In this case, we are given a very important piece of information. A node can be descendant of itself, which means 4 would be the answer in this condition. 4 can be an ancestor and a descendant. To solve this problem, we can make certain observations. In a scenario where we have 0 and 5, we can say that we can reject this right subtree because both of these values are lower than the root. Since it's a binary search tree, we don't have to worry about this subtree. And we can continue doing this to reduce the complexity of the problem. At the end, we can say that this subtree would contain the lowest common ancestor. Even though 6 is also an ancestor, it may or may not be the lowest common ancestor. So we can say we have a relation like we have a root node, which would be an ancestor node, and we have P and we have Q. These are the descendant nodes. If we found a relationship like this, where the value of P was less than R and the value of Q was greater than R, we can say that we found the lowest common ancestor. This can be in the reverse direction too, like P can be greater than R, Q can be less than R. If, if at any point we found something like this, we can say that the node over here is the lowest common ancestor. To better understand the problem, let's take a look at the code. So we are in the code editor. The first step, we need to reject the part of the subtree where P and Q do not exist. For that, I can write a condition if P dot value is greater than root dot value and at the same time Q dot value is greater than root dot value, I can safely reject the left side of the subtree and only select the right side. Since I know that the ancestor would be somewhere in the right side, I can return from here and I can call the lowest common ancestor recursively for the subtree. Something like this. Similarly, I can say that if the value of P is less than root dot value and the value of Q is also less than root dot value, then the solution exists on the left side of the tree. So I can return the function recursively for the left subtree. If I do not have this condition where P and Q exist on one side, which means they exist on two different sides, or either P or Q is equal to value. In this condition, I know I found the ancestor node, which is return root. Let's try to run this code. It's passing, but we are missing a condition. What happens when we reach the leaf node? We should make sure we are not going beyond the leaf node. So we can say if not root, we can return from over here. Let's submit this code. It's passing.